try.
Actually, what I will probably do is I'll put my headphones in with my phone and head on the radio broadcast of the Royals, and then I'll be watching the Chiefs.
Yeah, watching baseball is, depending on the game, it can get slow.
I like watching baseball in October. I don't like watching it in April, May, June, July, August, September. Hey, good morning.
Morning.
Just so you know, we are recording already. So,
Alright.
are you by yourself?
What you mean?
Screwed up?
And he should be coming soon. I don't
Okay.
know.
Alright.
It was a line at the.
Oh, it's fine.
Yeah.
When I got here, there were 2 buses, so I'm gonna assume that another one came.
Yeah, well, it's probably a long line. Okay, so we're gonna talk about unit circle today along with right triangle trigonometry a little bit, okay? So the first thing we'll talk about is what's the definition of the unit circle. Good morning. Morning. By the way, I'm recording, so if you don't want to be heard or seen. Okay, so there's 3 things we have to know about the unit circle, okay? And I'll get to them in just a moment as I'm slowly waiting to make sure Jade is ready because it's not a very nice look.
Did you restock up on your water?
Not yet. I've got.
Can you
Have
get
to
bigger
pay
water
them.
bottles?
What?
Can you get bigger water bottles?
No,
Why?
because I get it from the school.
Oh,
Number 1. Or capital letter A. The unit circle, first of all, what is a radius?
From the center of the circle to the edge of it.
Okay, from the center to the circle itself. Okay, so when I have a circle, I go from the center out, that's the radius, okay? So the unit circle has a radius of 1. Now, I don't really need to say this, but from geometry, what do I know about all of the radii of a circle? All the radii are exactly
The same.
the same, very good. So all the radii of the circle, of the unit circle, are going to be equal to 1. Second point. The center of the circle is at where?
The point.
And we're going to put that on a XY axis. So the center is going to be at the origin.
Oh yeah, we're
At 0, 0, or you could say origin. So at 0, 0, we call that the origin. And then number 3, or point number letter C. I don't know if you remember doing this. I can't remember if we did in Algebra 2. I'm thinking maybe we didn't. Did we do equations of circles?
No.
No.
Okay, I know we do in college algebra, we're getting ready to start that. I'm not so sure we got to it in algebra 2. So the equation is going to be x squared plus y squared equals 1.
Wait. Maybe we did.
Now what does that formula, what does that equation kind of look like?
X squared plus y squared over, I don't know exactly what it is, but it looks just like that, but it's divided by itself.
Hypotenuse.
Okay, so I was thinking more of a more famous formula.
Pythagorean.
Pythagoras, this is the Pythagorean theorem.
That's what I was thinking of. I don't even
So it's
know
like
why
a
it's
squared plus b
hypotenuse.
squared equals.
Why did I
and
say
then-
that?
And then c squared is like 1 squared is 1.
Yeah.
So this is really, it's just really the equation of using the Pythagorean theorem, okay? Where the radius is always exactly the same, the radius is always 1. Okay, that's where the equation of a circle comes from, so. All right. So those 3 facts about the unit circle, we'll come back and add to that here in just a second. Roman numeral 2. Whoops, back up. Roman numeral 2. Let's look at the trig functions, because the 2 of them, the unit circle and the trig functions kind of go hand in hand. Okay? What are the trig functions?
Sine, cosine, tangent.
Okay, so we have sine, which I'm going to abbreviate SIN, okay, the sine, and then the cosine, which we abbreviate COS, and the tangent, which we're going to abbreviate TAN. Now, what are they? What are the sine, the cosine, the tangents? I mean, they're trig functions, but where do they come from?
Where do they?
Yeah. How do we find the sine of something?
With Pythagorean.
Not very far from the truth.
Oh.
Mm,
Do you remember studying sine, cosine, tangent in geometry?
yeah, with SOHCAHTOA.
SOHCAHTOA, very good. So what did you have to have in order to use sine,
You
cosine,
had to have
tangent?
an angle of something, the length of a line.
You need to be more specific. What shape?
A triangle.
Triangle.
And what specific type of triangle?
Right triangle.
Right.
You had to have a right triangle. So, if I had a right triangle, something like this, okay, and then we have the three sides of the right triangle, correct?
Mm.
So this is always the hypotenuse. And how do we know it's the hypotenuse?
It's across from the angle.
Across from the right angle, correct? And it's the longest side. In this case, the hypotenuse is going to be the same as the radius. Okay, so let's go back to our drawing here. Notice if I take the radius here, or if I take the radius to make this hypotenuse, I can create a right triangle. If I take an angle over here, I can create a right triangle, and that hypotenuse is the radius. Okay? So we do things like that. Okay, so which one is the adjacent side?
The
The
left
adjacent
side.
is the one across from the hypotenuse. Or, no, across from the, one of the angles, and I can't remember
It's
which one.
the left one.
This one over here?
Yeah.
Sometimes.
Uh,
Sometimes it's this one. Okay. Remember, adjacent and opposite are relative terms. Hypotenuse is absolutely, this is always the hypotenuse. It's opposite the right angle, always, always, always. But the adjacent and opposite are relative, meaning it depends on which angle I'm looking at. If I'm looking at angle, let's say angle A,
oh.
now this is the opposite, and this is
that's
the
the
adjacent.
Yeah.
But if I'm looking at, let's say, angle B, now this is the opposite, and this is the adjacent. So they're relative, it depends on which ones I'm looking at, okay? So then, let's go back to, let's erase that, let's deal with angle A. Let's use angle A. Come on now, come all the way. Portion. And let's calculate the values of this sine, cosine, tangent. So let's calculate what is the sine of angle A. Do you remember what it stood for?
No.
Do you remember? SOHCAHTOA? Opposite over the hypotenuse. So the sine is going to equal the opposite over the hypotenuse. And notice it doesn't matter how big the opposite and the hypotenuse are. Okay, it could be this triangle here. It could be a bigger triangle, but the proportion's always going to be the same. Okay.
Oh, it's gonna be a right triangle.
Well, it's always going to be the right triangle as long as I'm doing the A. That sine doesn't matter how big the triangle gets, it'll be in the proportion of opposite divided by hypotenuse. Which, by the way, then, just a little side note, if the hypotenuse is always the biggest side, what do I know about the fraction opposite over hypotenuse? The hypotenuse is always the biggest side.
It's never going to be more than one.
It's never going to be more than 1. Okay. Will it ever be equal to 1? Yes. Talk about it later. But it's never going to be greater than 1. It's also never going to be less than negative 1. It has to be between -1 and 1. Because the opposite could be equal to hypotenuse, but it will never be bigger. Okay, so let's try this, the cosine. What was the cosine? Cosine of A is going to equal what?
Adjacent hypotenuse.
Adjacent divided by hypotenuse. And the same rule applies. If hypotenuse is the longest side, that will never be greater than 1 or less than -1. So cosine is adjacent over hypotenuse. And then the last one, the tangent. What is the tangent of A?
Opposite over adjacent.
Okay, however you remember it, SOHCAHTOA or,
I always just wrote it on my piece of paper.
say what?
I had to write it on my piece of paper. I
Yeah,
can't
there you
remember
go.
it.
In this case, you remember the old game Tetris, if the two H's fall out, it just falls. I have opposite over adjacent. And I don't care how you remember it. When I was in school, we didn't do SOHCAHTOA. My math teacher taught us a little poem. Orange hippopotamuses are hairy, obese animals. Orange hippopotamuses are hairy, obese animals. Or Oscar had a hold on Arthur. Anything to help you remember it, whatever it takes. Get a little poem, a little phrase. You probably saw, I know I've mentioned before, SOHCAHTOA. To me, that never really doesn't really make sense to me.
Makes so much sense to me.
That it,
SOHCAHTOA does?
Yeah.
I don't know
Beautiful,
why.
whatever helps you, have it memorized, okay? Now, those are the trig functions, right? Is that all the trig functions?
No.
no.
No, what are the other three?
Inverses.
Inverses, which are what?
They're the ones with
Sine -1.
Is it okay if I get rid of this?
Yeah.
Good, I'm going to. Not sine to the negative first. That's actually going to be a different concept. So what color should we use? Let's use yellow. Okay, so then we have what's called the cosecant.
Oh.
Isn't there?
Cosecant, which is simply going to be the opposite or the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant would be
Hypotenuse over opposite.
very good. Okay. And then the opposite of cosine would be
Secant.
secant, which we abbreviate the SCC. So that's just simply going to be like 1 over cosine, and therefore it's going to be hypotenuse over adjacent. And then what's the last one?
I remember.
So think about this just for a second. We have sine and cosine. I have secant and cosecant. So I have tangent and
Cotangent.
excellent cotangent. And we abbreviate that COT, and that's just 1 over tangent. So let's see, what would that be?
Adjacent over opposite.
Adjacent over opposite. This tangent is opposite over adjacent. So just take it before. Do you have a calculator? Are you in degrees or radians?
It doesn't say. Oh, degrees.
It does say that. Okay.
I was like, mine says that. Okay. Okay, so do this for me. I want to look at what this co means. Okay, just real quick. Co means. So let's take the sine and your degrees, correct?
Mm-hmm.
Let's take the sine of 30. What do you get?
0.5.
1/2. 1/2. Now, let's take the cosine, and then let's take its complement. What is the complement of 30?
15.
No. From geometry. Complement.
90.
No.
30.
No.
-30.
No.
What? Wait.
Ellie, what's the complement?
Is it 160?
Nope.
Oh wait, no, wait. 150.
Nope.
Really?
Really? You remember complements from geometry?
No.
Never.
No.
I'm sure you remember complementary angles. Two angles.
30,
that-
30, 90.
No.
Oh, so 30, 270.
No. Two angles when added together equal 90.
Oh,
So-
70.
30, its complement would be
Oh, not
60.
60.
60.
Not 70.
Because 30 and 60 equal 90.
Be 90.
Okay. So
I
complementary.
remember saying
Complementary, CEO, complementary. What is the cosine of 60 degrees?
Half.
Those are the same. Because it simply means the complement or the sine of its complement angle. So that's what those two mean. So you're going to see a lot of repeating things between sine and cosine, a lot of repeating things between cosecant and secant, a lot of repeating things between cotangent and tangent. Okay, so complement. Okay, so then, let's take this concept and let's go back, oops. Let's go, Roman numeral 3, I guess, go along. Let's put these things together. Let's see, I'm going to draw a perfect circle. I expect you to do the same. So make a perfect circle, just like mine. Perfect. You have a cup.
Huh?
Make a perfect circle. See, that was perfect right there. Look at that. That's a great circle. Yeah. All right.
Yeah.
So a circle. Okay. And then in there, let's create an x and y axis. So like a bullseye right there. So we've taken our Cartesian plane, we put a circle on it. Okay. First of all, is this a function?
No.
Why?
Because there's no points.
Nope. It's not a function, but why? What's the test to see if it's a function?
Vertical line.
Vertical, fails a vertical line test. I draw a straight line, it's going to hit the circle in two places, so a circle is not a function. Okay. So inside this one, let's create a triangle. I'm going to try and draw it right there as close as we can, and then create a triangle, make a little right triangle. Okay. Now, see if you've been listening. This distance right here, this hypotenuse, what is the length of that?
1.
1. There we go. And then this side down here we'll call x, and this side here we'll call y. Any idea why we call them x and y?
because of
The x squared plus y squared equals 1.
Okay. But this is on the x-axis,
Oh.
and this is the
Y-axis.
vertical y-axis.
Yeah,
This is going up.
yeah.
Okay, so we call it x, y. So this point can actually be called x, y. Okay. All right. So then, in trigonometry, we don't usually use letters to signify angles. We use Greek letters. Okay, and the most common Greek letter is theta. So we're going to use theta. Theta looks like a 0 with a belt. It's like a 0 or like an O with a belt on it. Okay. So what is the sine of theta?
Negative 1.
Say again?
Negative 1.
No. Looking at sine we know is what over what? Opposite over,
adjacent or hypotenuse.
oh, opposite over hypotenuse, right? So since I have a triangle, what's the opposite side?
Y.
Y over what?
X.
Opposite over hypotenuse.
Oh, 1.
Y over 1. So it simply equals y. So my y value on my unit circle will always be the sine. What's the cosine of theta? Cosine is what over what?
Adjacent,
Adjacent.
hypotenuse over.
Adjacent over hypotenuse.
Adjacent over hypotenuse, which in this case would be x over 1. So on a unit circle, the x is always going to be my cosine value. All right, what about the tangent of theta? It's not going to be equal to.
Which is opposite over adjacent. It's adjacent over.
Okay.
It's opposite over adjacent.
Opposite over adjacent. So that's going to be what over what?
Y over X.
Y over x. Can't go any more with that, right? However, y is called what? Y is the sine of theta, right? And x is the cosine of theta. So I could say that the tangent is going to be equal to the sine of theta divided by the cosine of theta. Now, if that's the case, let's go back to our rational functions, okay? What can x not be equal to?
1 or 0.
Why? Why can x not be equal to 0?
Because the hypotenuse is worded. It can't be worded like wait, no. that
Think
doesn't
about
make sense.
rational functions.
And a little while ago, you said that something couldn't. Oh no, that was something else.
He's kind of hitting on a concept where y over x, but that was with sine and cosine. They can never be greater than 1 or
Yeah.
less than negative. Okay, in this case, tangent, why can x not be 0?
Because it doesn't cancel.
Where's it located? Denominator. And remember, denominator cannot be 0.
Yeah.
So cosine can never be 0, or when cosine is 0, we have a problem. Alright, so x cannot be equal to 0. Because that would make the whole thing. Okay, let's do the last three. Okay, so what is the cosecant of theta?
And that's hypotenuse over adjacent.
Hypotenuse over opposite.
Opposite.
So the y,
1 over 1.
It's simply the reciprocal of sine. Simply 1 over y. And of course, we know then that y cannot be equal to 0, because y would be, so the cosecant has issues when y is 0. Okay. Secant of theta.
one over x.
1 over x, reciprocal of cosine. And of course, that has an issue when x equals 0. Cotangent of theta.
X over y.
So y. And what's the stipulation on that one?
Y equals 0. Could not equal 0.
There you go. Y cannot be equal to 0. Okay, so a little bit of trig functions around the unit circle. Let's actually look at the unit circle now. Are you guys familiar with it at all? Have you seen it at all? I know I haven't taught it in Algebra 2.
I somewhat
Top
remember
left.
what it looks like.
Through geometry?
Top
Yeah.
left.
The unit circle?
Oh, no, I don't know.
The only time you'd probably see it is in geometry.
I remember cheating off of it for a bonus question when I took the geometry quiz in here.
Okay.
That's the only thing I remember about the unit circle.
Okay, well, so we want to draw a unit circle, something like this again, and we're going to add to it. We're going to have you draw a couple because it always gets too congested. But I want you to kind of see where the values come from and how we get them, and then yes, you will need to know the unit circle backwards and forwards. Okay? Right, Ellie? You got to know the unit circle backwards and forwards? Yeah, okay. So when I go through it, the first thing we're going to do is we're going to look at all the radians. And then we're going to look at and match that to degrees, okay? So we know in a unit circle, let's see, what color should we use?
Green.
Green?
Yeah.
Which one?
The dark one.
The dark one, okay, make sure it works. Okay, so we're going to do that one in degrees. So we know that this is 0 degrees. This one up here is going to be 90. We know this one is
180.
180, and this one is
270.
270, and this one obviously then would be 360 degrees. Oops, that's 360. Now within the unit circle, we only use 3 lines in each quadrant, okay? So let's go and do the first one. Let's go ahead and cut this in half. If I cut that in half and cut each of them in half, how many degrees would this one be? Halfway between 0 and 90.
45.
45. Halfway between 90 and 180.
135.
Halfway between 180 and 270.
225.
And halfway between 270 and 360.
305. Oh wait, 315.
315. And those are all 45 degrees away from each other, right? Let's do that same concept but with radians. Okay. What color should we use for radians? orange. Okay, so with radians, I know that this is 0 radians, right? And I know that this is going to be pi radians. Okay? So what's right in the middle of 0 and pi
90.
in radians?
Oh, half?
Half of pi. So pi over 2.
Oh, I kind of remember this now. We did do this.
Did we?
Yeah, we did, but we didn't do anything with it. We just made it.
Oh,
Sure.
okay.
In geometry class?
Yeah, in geometry.
Okay. What did you have, Miss Beatty?
Yeah.
Yeah, she usually did. Because you were in geometry honors, right?
Yeah.
Okay. So what's halfway between 0 and pi over 2? Take pi over 2, or 1/2, and cut it in half.
1/4.
1/4. And if you think about it, if you think about a pizza, here's pi radians. Well, this is 1/4 of it, right? This is 2/4 of it. What would this be here?
Well, what?
What would that be? If this is 1/4, and then this is 2/4, this would be
3/4.
3/4. 3 pi over 4. And then, if you think about it, 4 pi over 4. Because that's 1 pi, right? What's going to be down here? Count 'em.
Just restart.
1/4, 2/4,
1/4.
3/4, 4/4,
1/4. Or 5/4.
5/4, 6/4. But we don't keep it as 6 pi over 4. What does that reduce to?
1 and 1/2.
Leave it improper fraction.
Pi, or 1 pi, 1, wait, what the hell?
Reduce 6/4.
3/2.
3 pi
Yeah.
over 2.
Oh, okay.
So I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. This one would be
7/4.
7 pi over 4. And then back here we would have 8 pi over 4, or 2 pi, because 8 divided by 4 is 2. And one portion of the unit circle is just the fourths. Okay? And we can see that our circle is divided up into 8 pizza slices. Kind of make sense?
Yeah.
Okay, so 45 pi over 4, 90 pi over 2, 135, 3 pi over 4, all the way around. Okay, let's do, you can do on the same one if you'd like. I'm going to erase this. So I can put some more in here. So let's see, we had 0, and we had pi over 2, and we had pi, 3 pi over 2, and 2 pi. Let's see, for degrees we had, this is 0, 360, we had 90, 180, 270. Then of course we had the 45s in there. The other one we're going to put in here is a 30, 60, 90. Okay? So one line here is, let's go at 30 degrees. And then 60 degrees. And then the same thing here. 60 and 30. So if I take pi and I break it into 6 equal parts, what's this one here going to be?
30.
30 degrees, or how many radians?
Wait, fuck. 1.
1 pi over 6, right?
Yeah.
I don't know why I switched colors. 1 pi over 6. So what's this one here going to be?
60, and then 2 pi over 6.
2 pi over 6. Which I can't leave it as 2/6, right? So what do I leave it as?
1 over 3.
So it's pi over 3.
Or pi, yeah.
Or 1 pi over 3. Okay, so this is 1/6, 2/6. What would this be? We're just counting.
1/2.
1/6, 2/6,
3/6.
3/6. What's here?
4/6.
What's here?
5/6.
And then 6/6, 6 pi over 6. And of course, we have to reduce, we don't leave it as 4/6, what we put in there. Reduce 4/6,
2/3.
2 pi over 3. So we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Okay, keep it going.
7/6.
Okay. Go ahead and write them in. Seriously. I'm a little off on my lines.
Just a little bit.
No, just a lot bit. That was horrible. Okay, so we said this was gonna be 7/6.
Yeah.
What's this one here?
8 pi over 6, and then we have to reduce it.
To what?
2 divided by that 4, and 2, that's 4/3.
4 pi over 3. Okay, so we had 7/6, 8/6,
9/6.
which reduces to 3 over 2.
Yeah.
And this one is gonna be
10/6.
10 pi over 6. And what does 10/6 reduce to?
To 5/3.
Yep. 5 pi over 3. So we have 7/6, 8/6, 9/6, 10/6,
11/6.
11 pi over 6, 12 pi over 6,
So 2 pi.
which reduces to 2 pi.
Wait, so you can't do like other increments besides like 30?
So that's a very good question. With the unit circle, we're gonna go every 30, we're gonna go 0, 30, 45, 60, 90, and keep going in that pattern. Anything else is not in the unit circle, but we can solve for it,
Yeah.
which will be half angle and double angle. We'll do those
Okay. All right.
probably 3, 4, 5 weeks. Okay. But on the unit circle, we only do those.
Okay.
We only do these angles right here. Which means that's the only ones you have to memorize. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. And then of course 8/4. Okay, kind of makes sense, the degrees and angles,
Yeah.
degrees and radians. I got one yes, kind of makes sense? Makes sense, kind of makes sense? How we got it? Kind of makes sense? What time are we out of here?
I have no idea.
8:50? Okay, about 6 minutes. Okay, so what we're gonna do, we're gonna pick up with this tomorrow. But what we're gonna do is with this unit circles, we're gonna calculate, okay, at every single point on here, at every one of these individual points, what's gonna be the cosine of the sine? Okay, so we're gonna find the sine and the cosine at every single one of those points. They are very related, and really all you're gonna have to know is that right there. And once we show you how to calculate them, you can go back and recalculate them. Those that will then translate to all other quadrants. So it's not as daunting as we may think. Yes?
Did you write 5/6 or 5/4
Where?
in the third quadrant? Or is
Right
that-
here?
Yeah.
That should be 5/4.
Okay.
Sorry. Because 5/6 is right there.
Yeah, I was confused.
Yeah, it should be 5/4. Remember 1/4, 3/4, 5/4, 7/4. Okay, so we'll look at those X and Y values tomorrow and start filling in the rest of the unit circle. Okay? All right, there's no questions? We'll end it right there.